In question number 5, we are looking for how to take this graph line here and represent it as a table, an equation, find the rate of change, also known as the slope, find the initial value, also known as the y-intercept. We've done a lot of work in 8th grade, so at this point in the beginning of the year, of how to take one of our representations, our function representation, and turn it into a different representation. So these are all going to be representing the same exact material. We're looking for the key features being the slope and the y-intercept, and how to find those key features on the graph, on the table, on the equation. If this video is not helping you and you are still struggling, you have a wonderful toolkit that talks about linear key features. It's color-coded with blues and greens and reds and oranges to identify those key parts. And at this point, we should be using those resources when we are struggling. So looking at number 5, in this case, we're going from graph line to these other pieces. I can take my graph and look for my good points, and I can identify those on my table. So for example, this is 0, my x is 0, and my y is 30 because this is x and this is y. Okay, so 0, 30, 0, 30. Looks like that. Next good point, if I go over to 1, I can't really know what that is. It's between 20 and 25, and using the graph, I don't have a precise enough value to be able to plug in a value there. So I'm going to have to calculate that after I get some other values. If I come over to 2, I can see very precisely that 2 is going through that point there at 15. That coordinate point is 2, 15. And again, 3 we're unsure about, so we're going to move to 4, and 4, when I'm over and x is 4, my y value is 0. Okay, so you might be seeing a pattern a little bit. Looking at our table, I'm going to circle this point. That point's special because that point's going to help us in our equation. When x is 0, what is our y value? That's our starting value. That's the initial value before anything happens to x. When x is 0, that's the same point. Here's the y-axis, and it crosses through the y-axis at the 30. That coordinate point there is 0, 30. That coordinate point is the y-intercept. The y-intercept. So down here, that y-intercept is 0, 30. Okay, that's a key feature. That's going to show up in our equation, that shows up in our graph, that shows up in our table. Every time that's an important value. Okay. Next piece that we're looking for, so we've got the y-intercept, we're looking for the slope. So looking at that on the table, on the graph, since that's what we started with, looking for 2 good points. As I had said, this is not a good point because on my graph I don't know exactly what it is. I can guess, I can estimate, but I don't know precisely. I do know this precise point right there, and I do know this precise point right there. Okay? So we're going to use rate of change, slope, on the graph, and we're going to make the stair steps, that change of y over the change of x. Okay? Change of y on a graph is your vertical change. Change of x is your horizontal change. And so when I made this shape, I'm just made out a triangle to get myself, it's like driving through city blocks. If a bird can fly this distance, right? But we've got to take the roads. My road's telling me to go 2 blocks down and 2 blocks to the right and then 3 blocks down. So we're seeing how far is that actually happening. The change in my y, well, my y started here at 2, right? The change in my y is my vertical distance. My y started at 15, right? So if I were to look at this, my y started at 15, and my y went to, the vertical distance here that it went to is 0. That's really easy for us to figure out. But just in case if our numbers aren't easy next time, let's actually do the process. In order to figure that out, I'm going to take my 2 distances. 15, take my distance, 15 minus 0 gives me a distance of 15. So this change in this y, this distance right here, is 15. But it's not really 15 because I started here, right? And to get to my next point, I actually went down. So If I went down on a number line, I'm starting at a 15 and I'm decreasing. So it's really a negative 15. The change of y is negative 15. Okay. My change of x, I started at 2 and I moved to 4, right? This distance on this line is between 2 and 4. So to figure that out, it's 4 minus 2 gives me 2. Now am I going in the positive direction or the negative direction there? I'm increasing on that number line. So it's negative 15 and the change of x here is 2. That equals negative 7.5. I'm sorry, I'm running out of room. I'll try to rewrite that so it's easier for you to read. Equals negative 7.5 for every 1. What that's saying is I could then make these steps. I could go over 1 for my x, and I would go down 7.5, and there's my point. I'd go over 1, right, and I'd go down 7.5. I could continue that pattern. I'd go over 1, and I'd go down 7.5. I'm making my stairs. I've got steep stairs here, okay? So we will be talking about whether a stair or whether your slope is steep or less steep, shallow, where we are in between there. Okay? So now that we know our rate of change, we're going to apply that to this table. Same exact thing. If I go down here, I'm going to move that change of y. It's negative 7.5 for every change of x of 1. That's the unit rate because it's over 1. Okay? I'm actually going to erase this so that I have some working room. And I'm going to bring us back here. Change of x is 1, change of y is negative 7.5. So if I'm going to increase by 1, then this tells me what I'm going to do when I increase by 1 for my x, then I'm going to decrease by 7.5 to get to my 1. Okay? So if I'm at 30, I'm taking away 7.5, and now I'm at 22.5. And that looks like a good point. So if I go back to there, we're at that coordinate point 1 and up to 22.5. That looks like a good estimate of where we would have probably predicted us to be. Doing this again, I should see this pattern just continuing. I'm at 1. I'm going to lose 7.5 over here, and it does give me 15, so I know I'm on the right track. I'm at 1, reducing it 7.5. 15 minus 7.5 gives me 7.5. And I would continue that again. I would I would add 1 here, and I would reduce 7.5, and that would get me to 0. So my equation is y equals my rate of change times x plus my y-intercept. My y equals my rate of change times my x values plus 30. That'll happen every single time. So y equals negative 7.5 times x plus 30. Remember, x is just a placeholder for you to put a value into. So in this case right here, if I were to look at this, that coordinate point there, my x is 1. So what would my y value be? If I didn't have my graph or my table, I could figure it out with an equation. Negative 7.5 times that 1, right? Because if we took this coordinate pair, that's negative 7.5. But I'm going to add 30 to that. So that's the same thing as saying 30 minus 7.5, and that will give me 22.5.